Okay, in this first recording, I'm going to attempt to solve the first four problems that you sent me, and I've already written them out here. So I'm doing this completely without any preparation, so I might get one or two of them wrong, I hope not, or I might have to back up and redo some, we'll see. But anyway, okay, the first one is called find the LCD. LCD stands for the the largest common denominator. And the denominator, of course, is the bottom part of the fraction. So basically what we're saying is find the factors of the denominators and look for common factors in the denominators. So just work through this one here. Just undo those circles that I just made. All right, so the factors of the denominator that are in common. Well, first we need to factorize it, I guess. Now, you can do some of this by inspection, by looking at it. I can see there's an x squared here and there's an x. So I know that the answer is going to have an x in it, okay, because there's a factor of x in each one. There's a y in this one, but there is no y in this one. So therefore, there's not going to be a factor of y down here. The 15 is equal to 5 times 3. So I'm going to cross this out and write 5 times 3. And the 9 is written as 3 times 3, or 3 squared. Okay. So what I'm doing is I'm writing these things out, the number parts, I'm writing them out as prime numbers so that we can factor out the prime numbers that are in each one. There is a factor of 3 here and a factor of 3 here, but not the 3 squared. Okay, so we can take out one factor of 3 and write it down here. There is no factor of 5 in the right-hand side, and therefore the largest common denominator between both of these things is 3x, in my opinion. Now, what it means to say that there is a common denominator of 3x is that both of these original expressions here can be divided evenly by 3x. So largest common denominator means that I can take 4 divided by 15xy, and I can take 3 divided by 9x squared. And if I wanted to, I could factor 3x out of both of these. Okay? Or I could divide, well, let me just say, just factor 3x out of both of them. So this is the same thing as 3x times, oh, I made a mistake there. Why did I make a mistake? Never mind. So these two things that I have here are kind of made out of space. This 4 over 15xy is the same thing as 4 over 3x from over here times 3 times 5 is 15y. Okay? So I factored the 3x out of that. And on this side, if I factor 3x out of the bottom, I get 3x times 3 from the 9 left over. 3 times 3 is 9. And x again, right? So that leaves another factor of 3x that is still there, but I cannot do anything with it because there was only one factor of 3x in the original fraction on the left side. I'm probably talking too much here. So you just look for the prime factors for the number parts, and for the variables also factor them out and find out how many factors of each kind. There's an x in each one. There's a 3 in each one. Okay. Largest common denominator was 3x on each one. Well, let's just do a different one now. Perform each operation and simplify. That's moving very slowly. Don't know why. Okay, stop that. Okay, so we have 4 over x plus y plus 6 over x squared minus 16. Well, the thing is, to add two fractions together, you have to have a common denominator. So it kind of relates to what we were talking about up here, okay? We need to make sure that the denominator in the fraction is the same. I don't know why this is moving so slow today. It's annoying. Maybe my computer is about to die. I've got 46% battery power. Okay, well, that's about where the similarity ends, okay, because basically to make a common denominator, to make these denominators look the same, we need to change one or both of them in the way they look, so it looks like the other one. The key to doing these common denominator rational expression problems is to recognize patterns. There are certain patterns like a squared, a squared minus b squared, a squared minus b squared, recognizing that this is 4 squared, right? A squared minus b squared has a pattern a plus b times a minus b. You just have to memorize that because you've done so many of them. Okay? So now this becomes x squared minus 4 squared. So this one stays the same. 4 over x plus y plus 6 over x squared minus 4 squared. But using this pattern here of x squared minus 4 squared, we have 6 over, instead of a squared minus b squared, we have x squared minus 4 squared. So a is like x plus b is like 4. And a minus b is x minus 4. Okay, so what I'm applying is this a squared minus b squared identity to the pattern that we have here. How did I know to do that? Because I saw the x squared, and I know that 16 is also a squared, and this difference, subtraction, the difference between squares is the rule here. So this becomes 6 over x squared minus 4 squared, which can be written as x plus 4 and x minus 4. Okay. Now, I think I made a mistake in the left side of this whole thing. I copied it down wrong. It was x plus 4. I thought it was x plus y. I was beginning to wonder, hey, wait a second. This doesn't make sense. This is a 4. That's, of course, why it was important to turn that into a 4, right? This was x plus 4. And the top of that was just 4 over x plus 4. So I told you I was going to make a few mistakes, okay? So we are now to the point where we have 4 over x plus 4 plus 6 over x plus 4, x minus 4. All right? Now, we want to make the denominators the same, but they're still not the same. This one has an extra x minus 4 in it, so we need to have x minus 4 on this side as well. But that's very simple. We just write it in on the top and the bottom. You can do that to a fraction. Multiply the top and the bottom by the same thing, and you have a valid equality. You haven't really changed it. So I'm going to put 4 times x minus 4 at the bottom, and x plus 4 times x minus 4 at the bottom, and 4 times x minus 4 at the top. This is still the same fraction, so I'm allowed to do that. These technically cancel out, right? I could cancel them out and we'd be back to where we started, but I don't want to do that because I'm going to use that fact. So now we have 4 times x minus 4 over x plus 4, x minus 4. We now have a common denominator. Okay, and now we can add the two fractions together. Remember, you cannot add two fractions together unless the denominator is the same. You can't add 2/3 plus 1/2 until you have a common denominator, for example. Right? You would need a common denominator, for example, of 6. To get a common denominator of 6, this is just nothing. This is just a completely separate example, right? You could multiply the top and the bottom of this equation by 2, multiply the top of this one by 3, and the bottom of this one by 3. Now the bottom of these are both equal to 6, and so we have 2 times 2 is 4 over 6, plus 3 over 6 equals 7 over 6. All I'm saying is you got to have a common denominator. Here we have one just the same. X times x minus 4 plus 6 is now the new numerator. Remember, when you add two fractions together, you add the numerators, but the denominator, the common denominator, is the same, right? It's like saying I have 2/3 of a pizza, you have 1/3 of a pizza, together we have 3/3 of a pizza, okay? And on the bottom of this is now the same denominator that we found common, x plus 4, x minus 4. We have added them together, okay? Now, having said that, it is possible to continue to work on this one. We could multiply these together and expand the whole thing. I don't know if that's what we want to do, but if you did, you would have x plus 4 times x minus 4, we already said, is equal to a times b, a squared minus x squared minus 4x plus 4x, they would cancel out, minus 16, 4 squared, right? And back to the top, you see that's that same fraction that we had, x squared plus 16, still over there at the top. Okay. Oops. All right. So, and oops, that's the wrong page. What am I doing here? Duh. How did that happen? This thing is confusing me. Okay, so the last part then might be, depending on if you have to completely write it out in this way, x squared computer is slow. I've got a Macintosh. Look at that. There's nothing else running here, just the recorder. X squared. Come on, please. Minus 4x plus 6 here, and x squared minus 16 on the bottom. Now, I never really like doing these things. I think it would be possible to try to factorize this even further in a different way, but I am not sure if we need to do that because I don't remember what the question was. It says, well, it says in simplify. So can this top one be factored even more? I might just leave that to you for now because I'm kind of tired. Two numbers. To factor this even further means we would be looking, I'm going to say that this could be the final answer so far, but to factor it even further means that we might want to look for two factors that when go together make this expression here. That means there would be an x and an x. Now, this could be a waste of time, I'm telling you that right now. Two numbers that multiply together to make positive 6. Go here and here. Now this all goes back to the FOIL thing, right? Remember FOIL? But it's special cases of x squared. We need first x squared, outer and inner, multiplying those things together, could be minuses here, and the last. And so two numbers that multiply together make 6. Well, that could be 6 and 1, 2 and 3, -2, -3, -6, -1. All of these could be multiplied together to make the 6 here. Did I miss any? And we also would need two numbers that add together to make -4. Well, I can't think of any. 4 and 1. Excuse me. 3 and 1 are not any of these pairs. -3, -1. I don't think we can factor this anymore. Not with any simple way. So I'm just going to say at this point, I think the answer is x squared minus 4x plus 6 on top, and x squared minus 16 on the bottom. Don't hold me to that forever. Okay, the next question was simplify completely. Well, this is one of those cases, I guess what we're going to need to do is factor as much out as the top and the bottom as we can, cross those things out, see what it looks like, and move on. So let's see, 4x plus 2 and 20x squared. I'm going to start with the bottom first, although I guess it doesn't really matter. You can factor 2 out of the top. 2 times x plus 1. See, you have 2x. Nope, that doesn't work. Always go back and check your steps each time, right? 2 times 2x plus 1. 2 times 2 is 4x, and 2 times 1 is 2. That gives us the 4x plus 2. Down here, well, certainly we can factor 2 out of all of these. Okay, so that's what we're doing. We're factoring common factors out of this thing. So 20 divided by, well, first I'll write the 2. 2 times how much is 20? 2 times 10. But it's 10x squared. 2 times 10x squared is 20x squared. Okay. 2 times 9 is 18. So 2 times 9x goes here. 2 times 9x is 18x squared. This was a 4. 2 times 2 is 4. Okay, so I decided we could factor 2 out of here because of that. Now, maybe we can factor more out, but I don't think there's a factor of 2 here, but this is 9. And so I don't think we can factor anything else out of the number parts. Okay, so now we have 10x squared plus 9x plus 2 on the bottom, 2x plus 1 on the top. We can cancel that out, cross it out, divide through, and this gives us 2x plus 1 on top, divided by 10x squared plus 9x plus 2 on the bottom. Okay. Is this simplified as completely as possible? I don't know. It's late, it's been a long day, and I'm trying to think, are there any special tricks that I could do with this? You know, when the first number here is not equal to 1, when it's anything but except greater than 1, the whole problem can become much more complicated. So I, again, might be wrong because I am tired. It's 8 o'clock at night, you know. So I'm going to say, look, if it's possible to factor this one more time, getting some kind of factor out of this, then there might be a 2x plus 1 in there somewhere. You know, that would be my suspicion, that there's a factor maybe of that in there, but I don't know right offhand. So I'm going to skip this for now. And again, my video recording is moving along. I think this might be the simplest form. I'm going to go to the next problem, and we can talk more about this one later, okay? Okay. But yeah, this could be the final answer. There are some rules for factoring ones like this, but I'm not sure I want to get into that right now because I don't know what it is you're supposed to know how to do. Because this one looks like it might be a bit easier. This is find the domain. Now the domain is values of the independent variable, in this case x, right? What are the values of x, or the input? This is function talk. You know, x is the input, f of x is the output. It could be written as y instead, but for whatever reason right now we're doing it this way. Okay, so what are the values of x that can generate a real number answer for this function? In other words, are there some values of x that if you put them into this equation, f of x is not defined, has no meaning? And usually that's going to happen when you're trying to divide by 0, right? You know you're not allowed to divide by 0, right? So are there any values of x that would result in dividing by 0? Well, in order to answer that part, we simply take the denominator, we set it equal to 0, and then we find the value of x that make the denominator 0, and those are the values of x that are not allowed, that are not in the domain. So the domain would be all values of x that are allowed. Okay, so basically, again, when you have a rational function, that means a function with fraction in it, with the variable in the fraction, you set that denominator equal to 0, find the values of x that make it 0, and then you say those are not in the domain. Now, do that first. Sometimes people might be tempted to factorize the top and bottom first and cancel out common factors, but that can lead to problems because when you put 0 into the equation again, although that might be easier to solve, it won't cover some facts down here. So, well, let's just say try not to factorize it first. Try not to cancel out terms on the top and the bottom first. You still can factorize the bottom. So the denominator is x squared plus 2x minus 24. And we're going to let that equal b to 0 and find the values of x that do that, okay? To help out, of course, we could use the quadratic formula to get this, but I would advise trying to factor it first. It's usually going to be a possibility and is easier. So what numbers can we multiply together to make negative 24 and add together to make positive 2? That will be the numbers that go here and here, right? Now whether it's plus or minus remains to be seen. But start by just writing down the numbers that multiply together make 24, unless you can think of it right away. Like 6 times 4, positive 6 times negative 4 is negative 24. If I didn't know that, I would have to sit here and write down 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5 and 6, 6 times 4. Well, then we'd probably start with the negatives and so forth. One of them has to be negative, so we say 4 times negative 6, negative 8, negative 12, and so on. 6 times negative 4, etc. Well, I've already found one pair because I've done this kind of thing so many times. 4 times negative 6 is negative 24. 4 plus negative 6 is negative 2. That can't be the right answer. It's got to be the other one. Negative 4 times 6 is negative 24. Negative 4 plus 6 is positive 2. So here's how it works. You see, so you write plus 6 minus 4. X squared. Oops, do that again. X squared minus 4x plus 6x gives us positive 2x. And the last, this is FOIL, right? First, outer, inner, last. 6 times negative 4 is negative 24. So we have done it. So what that means now is that we have factors of x plus 6 and x minus 4. And the trick here is this. If two things are multiplied together and equal 0, it means either one of those can equal 0 to make that true. So remember, we're just trying to find what are the values of x that make our denominator equal to 0. And the values of x will be the solutions to these now two new equations. If x plus 6 equals 0, that means x equals negative 6. If x minus 4 equals 0, that means x equals plus 4. So these are the values of x that make these things 0, that make x plus 6 times x minus 4 equal to 0, and therefore make our denominator equal to 0. If our denominator is equal to 0, then our original fraction that has that denominator will not be defined. F of x, oh my gosh, look at that, that was weird. F of x is not defined when x is equal to 6 and negative 4. How do we express this answer? Okay, go back down to the bottom. The domain is the set of all real numbers x such that x is not equal to 6 and x is not equal to negative 4. Okay, how do we actually write this in proper notation? There's lots of different ways to do it. So you could say x is an element of real numbers. I don't know what your teacher would expect here, but the domain is the set of all real numbers x such that, and I'll try this again, x is an element of the set of real numbers such that x is not equal to 4 and or x is not equal to 6. The important thing is the domain is all values of x except 4 and 6. There are various different ways of writing that. Now, our original question, original problem here was x squared minus 49 over x squared plus 2x minus 24. Are there any other values that make this true? X squared minus 49 over x squared minus 2x plus 24. Okay, are there any other values of x that would make this not true? Well, let's see. The top part of the equation, x squared minus 49, are there any values of x that you can put into that that are undefined? If you put negative values of x or positive values of x, you'll always generate a real number no matter what, okay? So I don't think we have to worry about the top part. I might be wrong. We could factor that, by the way. It could be x plus 7 times x minus 7. Remember that? Because this is the same thing as 7 squared. I always try to look at these things. Is there anything funny about this? Not really. So I think basically we've solved that one. Here's the answer. X is a real number, any real number except 4 and 6. Well, that's the end of that lesson, I think. So, to be continued. How do I stop this thing?